Today's topic, factoring ax squared plus bx plus c, is an extremely important lesson. In lesson 7.7, we talked about factoring when the x squared term had a coefficient of a 1. So now we want to talk about what happens when the a in front of the ax squared is not 1, is something different than 1, and how do we deal with that? It actually is similar in a lot of ways, but it also adds some new levels of things that we need to be able to handle and to do. We're going to show you a method, or actually two methods, to be able to handle it, and just please make sure this is one that we really focus on. It's an extremely important skill for going forward. So first, we're going to go through the steps, how to factor trinomials in the form ax squared plus bx plus c. First, remember, the very first thing we do is we take out any common factor of all the terms before we begin. Next, what we're going to do is we're going to make a list of those same factor pairs. This time, though, we're going to make them of both the a and the c separately. So remember in the last section when our a in the front of our x squared was a 1, we didn't make a list of factor pairs because obviously the factor pairs of 1 are 1. We only did the c. But now that we have a being a different number, we have to take that into consideration. Secondly, for the second step, we're going to use trial and error. To mix and match the pairs to get the b value. This is where it takes a little more effort to figure it out. This is where it's a little bit harder to try to get this figured out. Obviously, once we have our binomials, we check, make sure that they work. If you pick the correct pair, you're done. If not, try again. And this is a method that can be a little confusing, but more than that, it can be very frustrating. You could end up spending a lot of time putting in a bunch of answers and not getting what you're hoping for. So the trial and error way, you want to try to pick your pairs strategically. Instead of randomly. You want to have a plan. You want to try to help yourself get to the answer the easiest way you can, as few options as possible, as few trials as possible. So here's how this one's going to look. So I've kind of done the steps for you on this one. I just wanted to go through it with you. Certainly make any notes that you would like to make. So we have this polynomial up top. It's a trinomial because we see the three terms. Notice the a value is a 4, then the 13 for the x, and the 3. So for step 1, it says to make a list of all the factors of a. So 4 can be written in all these manners. 1 times 4, negative 1 times negative 4, 2 times 2, negative 2 times negative 2. Our factors of 3 can be written as 1 times 3 and negative 1 times negative 3. Now remember in the previous section we could always say, well, if the factors of c were adding together to get the 13, then we didn't have to even consider the negatives. Well, you can't always do that in this method because we have another number out in the front, which is the 4, to keep in mind. It's not just all about the c. So let's try some combinations. So we're going to go with the idea that we have to have positives because both c and b are positive. So here in the first example, I'm just plugging in the first pair of these, the 1 and the 4, and the 1 and the 3. So the factors of a's are going to go where the coefficients. So 1x and 4x is where the 1 and 4 comes from. The 1 and the 3 are the numbers in the back where the c is. But when I FOIL this one out, I get 4x squared plus 7x plus 3. That's not going to make it. Then I move on to the second pair. I look at 2 and 2. So 2x and a 2x. Those numbers go in front of the x's. And I'm going to use the 1 and the 3 again to see how that one works. And I get 4x squared plus 7x plus 3 again, not the same. Then I have to start trying new combinations. So I'm going to go back to the 1 and the 4 that we started with. So this pair up top. This time, however, I'm going to alternate and switch the 3 and the 1 from the second pair. And lo and behold, there is where you're going to get the trinomial you'll need. So the factored pair is 4x plus 1 times x plus 3. that's the one we're going to use. So let's move on to the second one. So this time we've got a value. So we have our 3's. We get the 1, 3, and the -1, -3. And the 2 is my c value, so those are my options. Try some combinations. Now this time, because we're trying to create a negative number in the middle, both have to be negative or both positive, but because they have to be a negative, they both must be negatives. So here's where I'm going to try this. The 1 and the 3 and the -1, -2 does not work. But then I stay with that 1 and that 3, and I look at the -1, -2, but I reverse them. So I put the -2 in the first binomial, the -1 in the second binomial, and that one does work. So that would tell me that factored x minus 2 times 3x minus 1 is the factored binomials. So while this can be effective, and it's something that if you get good at it and you can deal with the frustration and keep yourself neat so you know what things are supposed to look like, it can be very effective. But it is potentially very frustrating when you try all kinds of combinations and it's just not working out. So there are other ways to be able to factor. There are certainly other methods, but I'm going to use this method called the factor box that is trying to put our terms into a form where we can kind of use our greatest common factor to help find the binomials. So this page is really not much for you to do. We're going to focus in, though, on how this looks, and then on the next coming pages we'll try some. So you're going to make a box that is 4 squares, and what's going to happen is when you get this ax squared plus bx plus c, the ax term always goes in the upper left-hand corner, and it always goes there. The c value always goes in the lower right-hand box. Now, these middle two boxes, we have a little bit of work to do. What happens with the middle two boxes is that we are going to take the a and c and multiply them together. Once we have that product, we are looking for the sum that equals the b. So similar to what we did in the last section when we really had c times 1, we looked for the factors to add up to the b. This time, though, we have to take the a value times the c value to look for the sum that gets the b. Now, once we have that pair, then that number and that pair is going to go into these two diagonals with the variable. So it might be 6x and 2x. So there'll be some sort of an x in those upper and lower diagonals. So then what we do, once we have those boxes filled in, then you can see here, we're going to go across each of the rows and say, what's the greatest common factor? Go across the lower one, what's the greatest common factor? Then we come down here and say, what's the greatest common factor? What's the greatest common factor? And those become our binomials. And just like anything we do, we want to check it. So we don't want to leave this problem unless we know we've checked it and that we know that it works out. So I know this is kind of a just hoping and seeing kind of one. I'm going to have to go through one with you, and then we'll try a few right from scratch. So a couple of things we want to keep in mind down here too. If there's a common factor in all of our terms, make sure you take it out first. You need to take this thing out before you get into the box. It has to come out so that the numbers work out. So the factor box doesn't always give us the exact signs. It will give us the correct terms that go into the binomials. Every once in a while, we don't get the right signs, and that's just a matter of you, when you do your check, just tinkering with the signs a little bit to see how it needs to be adjusted, but most of the time it works out fine. You also want to fact out a -1 when the a value is negative to make the a value a positive. Alright, so a lot of stuff that probably doesn't make a whole lot of sense at this point. Let's try some and see what they look like. Alright, so here's one that, again, I have done for you, and we're going to kind of talk through it, and then we'll try one from scratch. So when we see ax squared plus bx plus c, remember we said the c value goes into this lower right-hand corner. The a term goes into the upper left-hand corner. So then we come over here to figure out our a times c. Well, a was a 2, c was a negative 7, so we're looking for factors that are a negative 14. Then what we want to do is we want to find the sum, and in this case, the sum needs to be a negative 5, because the b value is a negative 5. So when I look through all the different combinations that I had, this one right here is the one that worked. 2 plus a negative 7 multiplied together gives me my AC product. Added together gets me my B sum. So then this is where the 2x and the negative 7x come into play. Now, I know a question we get every year is, what if I put the negative 7x up here and the 2x down here, and that does not matter. It won't matter whichever way those go, as long as they're in the upper right hand or the lower left hand diagonals. So now that the box is filled in, this is what it would look like. We're going to find our GCF. So basically when we find the GCF, what we're kind of doing here is we are saying, going across 2x squared and a 2x, there's a 2x in common to both. Negative 7x and a negative 7, there's a negative 7 in both. Coming down, 2x squared and a negative 7x squared, all that's in common right now is in x, and 2x and a negative 7 looks like nothing, but there's always a 1 in common. So with this in mind, I think 2x minus 7 times x plus 1 comes from this down here for the x plus 1, and the 2x minus 7 from here. And again, I need to check it. If I use my FOIL, I get 2x squared plus the 2x minus 7x. Those two go together to get the negative 5x, and the negative 7 on the end. It checks. So that would be our answer in a factored form. So let's try one from scratch so you can see it really all develop. So here on this one, we're looking at 6x squared plus x minus the 12. Well, right away, 6x squared goes in the upper left hand. The negative 12 goes in the lower right hand. My factors of a, c. Well, the a is a 6, and the negative 12 is a c. So I need negative 72 factor pairs. And I need the sum to be a 1. Okay? So 72 has an awful lot of pairs. A lot of pairs. But think about a negative 72. I need one positive, one negative. That when I add them together, I get a 1. So really I want two factors that are really close to each other. Well, if we think about our multiplication tables quick enough and long enough, I could think 6 and 12, but they're that far apart. I could think, I don't know, what's another one? 4 and 18? That's a long ways away. But remember, the 9 and the 8 make 72. Now, because I want to add them together to get a positive 1, I want the 8 to be a negative, so that when I add them, there's my 1. So again, now these are my diagonals. And I'm going to put 9x up here, negative 8x down here. Remember, this is where the x's go with them. And again, it doesn't matter. You do not have to have them in that way, but they could go the opposite two diagonals, and that would be fine. But now I'm going to go across. So if I look at my 6x squared and 9x, I see 3x in both. Negative 8x and a negative 12, a negative 4 in both. 6x squared and a negative 8x is 2x, and a 9x and a negative 12 is a 3. So that means we believe the answer is 2x plus 3 and 3x minus 4. And again, as a check, 2x times 3x is 6x squared. 2x times negative 4 is negative 8x. 3 times 3x is 9x. 3 times negative 4 is negative 12. I can put together these two terms to get 6x squared plus x minus 12. It checks. That is my trinomial factored. All right, so first we have something that we want to take care of here. So we talked about having the a value as a nice positive number. So what I want to do first here is I want to take out the negative. That's going to change a little bit in here to this trinomial. I still need it to equal the same thing, so I don't want to lose the negative sign. It has to stay there. But what I want to do is I want to make sure that I can factor with a 3w squared plus 2w minus 8. So again, my new AC, if I look at A and C, I'm going to put in a 3w squared. I'm going to put in a negative 8, which means 3 times negative 8 is negative 24. So I'm looking for factor pairs that get me a negative 24 that add together to get a 2. Now again, because I'm looking at a negative set of factor pairs, I want something that's positive and negative that is close enough that when I add them, I get a 2. Well again, you want to use your number sense. Ideally, we would see pretty quickly that 6 and 4 would work. One of them has to be negative, but I want a positive 2, so the negative 4. And when I add those, I can kind of verify that. That's going to mean that 6w and negative 4w come in over here. Okay? So, next I'm going to use my greatest common factors. When I come across, I see 3w's. When I come across, I see a negative 4. Now I know we think greatest common factor wouldn't be a negative 4, it would probably be 4, but the idea is we're taking out as much as we can and we want to bring out the negatives with it. In here, we're going to get w's. In here, again, we're going to end up taking out 2. So here's my factored form. So I think it's going to be w plus 2 and 3w minus 4. But we got to make sure that we remember that we have this little negative here that we started out with that we can't lose. Our factored form still has to equal what we started out with. So as I do my check, I'm just going to leave that on the outside for the moment. As I do my check of the FOIL, w times 3w is 3w squared plus 6w plus minus 4w minus 8. And then when I distribute through the negative sign, there I get my 3w squared minus 2w plus 8. So that would again tell us this now is my factored form. I'm going to darken that so we don't forget the negative. This one's an important one. Again, the very first step we'd always talk about when we're factoring is there a greatest common factor? Well, don't just start rushing off into the box and trying to get stuff going. I can see immediately that my trinomials all have a 2 in them. I need to take that 2 out so that this will end up working out. So don't forget the 2. And then make sure we keep the 2 all the way down at the end. So again, in our factored form, we should have something down here that's going to include that 2. We can't leave the 2. It's not just disappearing. We're just pulling it away to get out the greatest common factor first. So now when I start looking at my AC, my AC is actually 4 and a negative 6, which is negative 24. Our sum is a negative 5. So now I'm trying to find some factor pairs that are a little bit further away than we had on those previous ones. Negative 24 should be one we're okay with. We have one positive, one negative. When I start looking at the numbers that are a little bit more separated, hopefully we're going to see 3 times 8. One of them has to be negative. The negative 5 means, though, that the negative has to be with the 8, because that is the sum, which is a negative 5. So now when I come over here to plug in to the box, I'm going to plug in 4g squared. The negative 6 is the c value. I'm going to plug in negative 8g and a 3g. So here I go and I do my greatest common factors. I would get 4g on the top row. I'm going to get a 3 on the bottom row. I'm going to get a g, and I see a negative 2. So g minus 2, 4g plus 3. So when I go to do this one, I'm going to actually get, first, we're going to leave the 2 for there for the moment. G times 4g is 4g squared minus 8g plus 3g minus 6. Then I have to finish this off by multiplying and distributing the 2 all the way through. There's your 8g squared. The negative 8g and 3g is our negative 5g, which is negative 10g, and 2 times negative 6 is negative 12. So we've checked. So our answer here is going to be, in factored form, 2 times g minus 2 times 4g plus 3. So you can certainly use either of these methods. There are other methods out there. If you want to investigate those and look into those, that is certainly fine. The biggest thing, though, is this is a huge skill that we must know how to do, is to factoring our trinomials in the ax squared plus bx plus c form. So we really have to find the best way that works for you. I believe this box method a lot of us will use. It'll help to keep things a little more simplified. But again, if you have a different way that will work, and as long as it's a proven way, there is certainly no problem with that.